wood chips, rice husks, manure, sewage sludge, and biogenic waste. Whatever you have, dry or wet, it holds energy. Step inside the AHT modular system and see how it transforms residue into syngas, power, heat, and molecules like hydrogen and carbon. Designed to scale from 50 kilowatts to 15 megawatts, each AHT system and module plays its part. Gasification, gas conditioning, water treatment, and energy conversion. Everything begins with feedstock, and feedstock starts with your residue. There are two types of feedstocks, dry feedstock and wet feedstock. Dry biomass like wood chips, rice husks, or pellets might be shredded or briquetted for efficient use. Wet feedstock like sewage sludge or manure, on the other hand, aren't ready yet as they are high in moisture. That's where HTC comes in. It compresses and dewaters wet biomass, transforming it into hydrochar, a solid coal-like fuel. Once prepared, both types flow into the reactor, ready for gasification. Inside the Twin Fire Reactor, two zones operate in parallel. A downdraft zone for drying, pyrolysis, oxidizing, and reducing at 100 to 1100 degrees Celsius, and an updraft zone for oxidation and reduction at up to 800 to 1100 degrees Celsius. Next comes the gas conditioning, and it is a series of processes according to your demand of purity. The total processes consist of an enthalpy cooler, hot gas filter, heat exchanger, wet scrubber, spray column, ESP, a cold gas heat exchanger, and a gas blower. The process starts when the syngas first enters the enthalpy cooler, where water is injected into the syngas, making the gas suitable for the hot gas filter. From there, it then enters a hot gas filter to filter out fine particles within the syngas. And then, it enters the heat exchanger, where the syngas is cooled by transferring heat to another medium, making it ready for further purification. Here, the syngas is already suited for thermal applications, or for further purification. Next, the gas then flows through a wet scrubber, where wash water is used to remove condensate tars and soluble impurities. Then gas enters a spray column, where a water-gas mixture is sprayed onto the syngas, cleaning it from further impurities. After that, a wet ESP then further strips any remaining particles and aerosols from the wet gas stream. Finally, the gas is cooled via a cold gas heat exchanger, drying residual moisture, tars, salts, and sulfur, completing the gas cleaning process. As a result of these stages, an ultra-clean syngas with less than 10 milligrams per cubic meter of total contaminants is produced, ready for power or fuel. The system then recycles its wash water in a closed-loop water treatment system. Within the loop, flocculants cluster particles and flotation units lift contaminants to the surface. Through this, the system has achieved a closed-loop water cycle. Finally, the last stage of process, energy conversion, begins. As the clean syngas is blown into the CHP unit via gas blower, it powers a gas engine or turbine, generating electricity up to 40% efficiency. Waste heat from the process is also captured and used for process heating, drying, and more. Then, recovered heat is stored in thermal storage, industrial chillers, or buffer systems, supporting processes like backup energy even months later. Furthermore, by integrating our patented hydrogen technology, high-purity hydrogen can also be extracted from the syngas. With that, our gasification process is complete. Every residue tells a story, and we turn that story into decentralized clean energy. Because at AHT, clean energy is not an option, it is the foundation. To explore how your residues can be converted into the most valuable resources, visit us at our website, and thank you for watching.